Okay, we're on page 3 of the end of the year test. We're looking at number 16. So Kenneth graphed the triangle A prime, B prime, C prime by dilating triangle ABC. Which of the following must be true? So, so we went from ABC. He did something. He dilated it to get to A prime, B prime, C prime. Okay, so what must be true? Well, if he's dilated it, the ratios will be the same. So A seems to be the correct answer. Let's check the other ones. B says the area of A prime, B prime, C prime is greater than the area of A, B, C. Now that might make sense to you if the dilation was larger than 1. But remember, a dilation can also be less than 1. So he could have gone from, in order to dilate it, he could have gone like half size. Okay, that's still considered a dilation. So if you're going to multiply by half to get to A prime, B prime, C prime, that's not going to be true of A, or I'm sorry, of B rather. So not necessarily for B, not necessarily. All right, triangle ABC is congruent. Well, let's look at that word congruent. Congruent means the same shape and size. So it's not the same size because it's dilated. We don't know how much it's dilated, but we know that it's not going to be the same size. And then triangle ABC is an isosceles triangle. I mean, I guess it could be, but it doesn't have to be. It's certainly not. All right, so D is not the answer. The answer is A. Let's move on to number 17. A cell phone company charges $40 for their phone plus a monthly service charge of $25. So the equation below describes the cost after X months. All right, so $40. See, what is? Oh, sorry. What is true of the relationship between X and Y? It is linear proportional. Is linear non-proportional? It's not linear. So basically, we want to know: is it linear? Is it proportional? So remember, when we're looking at a linear equation, this is like y equals mx plus b. All right, so it's a linear equation. It follows our rules for a linear equation. So linear, yes. Not, we can cross those off. Is it proportional? Remember, our rule for proportional is that it has to go through the origin, which means that the b would equal 0, and in this case it does not. So it is non-proportional. 17, the answer is B. All right, number 18. A cheetah's speed was timed over a 50-yard distance. The cheetah was clocked running 60 miles per hour. Which equation shows the relationship between the distance y and the time x that the cheetah runs? Okay, so they're giving us some information here. This 50-yard distance is actually something we don't need. Okay, what we do need is 60. 60 is our rate, right? It's our miles per hour. So our m is going to equal 60. And so looking through the options here, the two that we've got are those. So we're going to cross out A and C, and let's look at B and D more closely. It doesn't make sense for us to choose B, and here's why. When you've got a speed, the speed is the rate, and if the cheetah's always running at 60 miles per hour, doesn't matter what the distance is. So it is a proportional relationship that does not include 50. The 50 is just extra. It's just extra information in the problem. Let's look at number 19. Which expression can you substitute in the indicated equation to solve the system of equations below? Okay, so remember when we solve a system of equations, we can graph them, we can substitute, we can add them together. In this case, they're substituting. So they're basically solving for one variable and then substituting it in the other equation. So what they're asking for is, like, what can you substitute in this first equation? And if you'll notice, all of these are for the y in that equation. So what we need to do is figure out what can we substitute from this equation into this one for y. So what we're going to do is take that bottom equation and solve for y and see which of these over here will get substituted in for y into this equation. All right, so let's look at that. So let's take 3x plus y equals negative 2. So if I'm solving for y, I need to subtract 3x from both sides. And that leaves me y over here. And over here I've got, I'm going to write negative 3x minus 2. All right, so I'm looking for y equals negative 3x minus 2. That's what we're substituting. This, I'll put a different color. This is what I'm going to substitute into the y in this equation. So which of these makes sense? Well, it's A, because I got negative 3x and minus 2. All the other ones are wrong. So our answer for 19 is A. All right, let's look at 20. What is the solution to the system of equations shown below? Again, you can graph it, you can substitute it, you can add it, but I see that this is a negative here, and there's a positive for the x there, and that 2 is actually a factor of 4. So I can multiply this whole equation by 2. Remember, I'm going to multiply both sides. And then that's going to give me negative 4x plus 10y equals negative 24. Okay, and then I can take the equation below it, and I can add these two together. Because when I do that, I'm going to get rid of the x's, and I'm going to be left with just the y's, and then I can take the answer for y and substitute it into one of those equations. So I'm going to add these two together, and so negative 24 minus 2 is going to be negative 26 over on this side. 10y plus 3y is 13y, and these two are going to cancel out, so I don't have to write the x at all. So I've got 13y equals negative 26, and I'm going to divide by 13 to get y by itself. That's going to give me negative 2. Okay, so if y is negative 2, I can take one of the equations from above and substitute it. So let me see. I get a little bit more space up here. I'm going to take negative 2x plus 5y equals negative 12. And I'm going to substitute it with this negative 2. Okay, so instead of writing y, I'll write negative 2. So negative 2x plus 5 times negative 2 equals negative 12. I'm rewriting the equation as negative 2x minus, because 5 times negative 2 is going to be a negative. You could say it's plus negative 10, or you could say it's minus 10 equals negative 12. Now I've got to get, let's move that negative 10 over to the other side by adding it back. I'm going to add it back over here. That gets rid of that, leaves me with negative 2x is equal to, and then negative 12 plus 10 is negative 2. All right, so negative 2x equals negative 2. I'm going to divide both sides by negative 2 to get x by itself. So now x is equal to 1. All right, so if I've got x equals 1 and y equals negative 2, I need to write that in a coordinate pair that looks like this, x comma y. So my x value is 1, my y value is negative 2. And so now I'm going to look for the answer that matches that, and that is D. All right, now you could have done it a different way, but I chose adding the two equations together. All right, looking at number 21, Ryan drew a cylinder and a cone with identical bases and heights. Which of the following is true? Okay, well, first of all, we have not gotten to this yet, but we did work on it in the spiral review in the mornings. So remember, if you've got a cone and a cylinder that are the same height, so you've got the same height, and let's see, you've got the same radius here. Remember that the volume for a cylinder is equal to the area of this circle, which is pi r squared, times the height here, so times h. The cone, the volume for a cone is equal to 1/3 of that. So you could fit 3 of these cones. Let me see if I can find it, do a different color here. 3 of these cones here into the cylinder that it fits into. So the volume of the cone is 1/3 of pi r squared times the height. All right. Anyway, so now knowing that, let's look through what we've got. So A, the volumes are the same. No. The volume of the cylinder, the big cylinder, is 3 times the volume of the cone. Yes, that's exactly what I just said. That's going to be our answer. And let's look at the other ones to make sure that we understand the wrong. The volume of the cone, for C, the volume of the cone is 3 times the volume of the cylinder. They've gone backwards on that. If you look at it, they're saying that the volume of the cone is bigger when we know that the volume of the cylinder is bigger. So that's the opposite of what we want. And D, the volume of the cylinder is 4/3 the volume of the cone. That's not taking into account the 1/3 that we've got there. Okay, so let's look at number 22. I think that's it. We'll be all done after this one. So how can the diagram below be used to explain the Pythagorean theorem? Well, here's a triangle that we can use to remember the Pythagorean theorem. If that's A, and that's B, and this is C. Remember that. A squared plus B squared equals C squared. Well, we can see from this that since this is a square, this is A and this is A, the area of this is A squared. And the same goes for these. So if this is C and this is C, the area here is C squared. And, whoops, wrong color. This is B and this is B. The area of this is B squared. So it makes sense to say then that the area of the black square is equal to the sum, right? Sum of the areas of the gray squares. So that makes sense. Let's just look at the other ones to see what's wrong with them. So for B, the sum of the areas of the gray squares is less than the area of the black square. Well, that's not what this says. Okay, this says equal to. The sum of the areas of the gray squares should be equal to the area of the black square. The sum of the the sum of the areas. So the perimeter of the triangle is equal to 1/4 of the total perimeter of the 3 squares. That doesn't make sense at all. That has nothing to do with the Pythagorean theorem. And then the area of the black square is equal to the area of the triangle. No, it's a lot bigger than the triangle. Yep, A is the best. That is our answer. Well,